Hi there, and welcome to the Air Equipment LLC YouTube channel. This is part 3 of our topic, Life Safety Dampers. The fourth and final category of damper is the ceiling damper, often called a radiation damper. The ceiling damper is designed to block the passage of flame and heat. As we mentioned in an earlier episode, if there's a fire in the room and all that heat rises, it could pass right through the damper and set something on fire up above. So in addition to having metal blades which block the passage of flame, these dampers also have some insulation material, often sheetrock or some kind of refractory fiber material, mounted to the back of the blades. As you can see in this photograph, it's a butterfly damper. It's a round damper designed to mount in the neck of a diffuser, and when the fusible link melts, the two blades snap shut, and there is steel in the blocks the airstream so that no flames get past, and the sheetrock mounted to the back of the blades prevents heat from passing up through and setting something on fire above. Quite often these dampers are used in ceiling diffusers, and as you can see here, this is a lay-in panel type diffuser, so that's probably about a 8 or 10 inch neck with the damper mounted in it. There's a lot of the diffuser panel exposed. In order to do the installation properly, there has to be some kind of insulation blanket mounted on the back of the panel as shown here, and so the entire assembly is then valid, a ceiling radiation application that prevents the passage of flame and heat. It's very important that the fire dampers are installed properly. This is an illustration showing a damper being mounted in a wall, and the blades of the damper, when they are in the closed position, must be within the plane of that rated partition, that wall or floor. And the damper assembly, both the damper itself, its frame, and the sleeve, have to be mounted securely to that wall so that they won't move. As we mentioned in a previous episode, the breakaway connections are really important. If something collapses onto the ductwork, the damper and the sleeve have to stay in place. So first, how the damper is secured to the wall is with mounting angles. You can see on the left side, it's labeled fast angle, and that's Ruskin's name for their one-sided mounting angles. They've had this tested and approved by UL. You no longer need to use two sets of mounting angles, one on each side of the wall. Now you can do it with one. The horizontal part of that flanged angle gets secured to the damper sleeve with screws, and then the vertical part of the angle gets secured to the wall itself. And this is on all four sides of that damper sleeve. So that's what holds the damper in place in the wall. And then you have your breakaway connections where the ductwork is connected to the damper sleeve, and it's sealed so there's no air leakage, but it breaks away if a weight, something collapses, lands on top of that duct, it'll snap away, and it'll leave the damper, the frame, and the sleeve in place in the wall so it can do its job of protecting that rated partition and preventing the passage of flame from one side to the other. Now, when dampers are installed in walls or floors, it's important to have a clearance. We call it an expansion gap, because what happens is when that damper gets really hot, if it ever has to be used, it's going to heat up from room temperature of 70 degrees up to maybe 200-300 degrees, and that metal that it's made out of is going to expand. And if the damper is installed really, really tight to the wall, what happens is when the metal expands, it has no place to go, and it kind of racks in place and gets out of square, and then the blades won't close. So there has to be a gap. When it's installed properly, there is a gap, anywhere from 1/4 inch, sometimes up to 3/4 of an inch, depending upon the actual size of the damper. And that's required so that when it does expand, it will stay square and the blades will close completely. In this illustration, the damper itself is shown as the orange material, and the yellow indicates that expansion gap. It's required, and it gives that damper room to move. Now, you might look at this and say, wait a minute, there's an opening. You could get smoke or flame could pass right through there. But actually what happens is when you install the mounting angles, those angles cover up the gap. So there is some metal, there's some steel in the way. It does not allow smoke or flame to pass through, but it does allow the damper itself to expand if it gets hot. So that way it will actuate, it will close the blades and do its job. Sometimes we have a situation where there's not enough room to mount those mounting angles on all four sides of the damper sleeve. And it is required to do it properly to have it on all four sides. But there is an alternate method shown here. And this would be in a case where, say, the ductwork, the very top of the ductwork is pressing up against some structural steel, and there's simply no way to get the mounting angles on that top side. So what can be done is these little L-shaped brackets, these little angle clips, are used, and you can see in this photo they're screwed into the damper sleeve and also into the wall, and they are used to hold it in place. They take the place of the mounting angles to perform the function of keeping that damper in place no matter what happens. But then, because we can't put a mounting angle, which normally covers up the expansion gap, we have to use a special FIRESTOP caulk material. And there's Hilti offers one, Spec Seal or John Manville Fire Temp CI is a good product. Also Rector Seal makes products. And simply what you do is the installing contractor will seal all around the damper sleeve to make sure that there's no opening directly communicating from one side of the wall to the other, and then also put a bead of this caulk all around the edges of the mounting angle, and that is a valid UL approved method of installing the damper without using the typical mounting angles, but it has to be done exactly the way UL prescribes, and this is done when there simply is not enough room to put the angle on all four sides of the sleeve.